Alright guys, so I'm doing a video in an unscripted fashion so I can listen to music at the same time, and so you can't listen to it because probably it's copyrighted, but if you care about it, go check out Lane Trzaska or Ed Harrison or Kevin MacLeod, I guess. That one isn't copyrighted, but whatever. I've spent a lot of time and effort designing a lot of devices which I'll probably never manage to build because not have enough money, but I lacked all the resources. But I have quite fun doing it, so I'll instead just explain to you how I got to them, how managed to conceive these devices. So for example, let me just pull my notebook here, point out something. Let's see, I'm new to video making and this will be really clumsy. What tools I use? Yeah, that's something I should mention. So for example, to test and draw electronic schematics, I use this thing. It's Falstad, and this isn't secure my ass, so Falstad circuit simulator, and you can see these nice graphs here of the voltage and current of the various devices, and if I push the switch, watch it go wind up, and then it releases and starts sloshing around or springing around. This is a springing circuit, or water sloshing circuit, as they call it metaphorically, like in a tank of water which sloshes the water. If you shake a water bucket or something, the water sloshes around. This does the same thing, so but for electricity. So as you can see, there are many wow, this is a cool one. There are many circuits that, for example, many example circuits. Let's try an interesting one. For example, this stupid oscillator I don't really understand, but whatever. It doesn't really do sine waves. I think this is just really distorted square wave like thingies. I wonder if there's a Wien bridge here. Wien, or is it Wien? Wien bridge, probably. These German names, like there's a Schmidt trigger too. Yeah, sure, why not? Is it Schmidt? Whatever. And I don't think there's Wien bridges there. Maybe in op-amps, no? There's another Schmidt trigger, but implemented on op-amps. Schmidt triggers are always cool. They are what I call, if I was to name them, it would be hysteresis devices. We can talk about system theory and another time. I don't think there are... maybe... sine wave oscillator. Okay, no, this is not Wien oscillator, but does some kind of output. This is actually a phase shifting technique, whatever. So it's a very... I think I've built one of these and managed to make it work, but they are unreliable ways of doing sine wave oscillators. But what the most interesting part is that you can have a blank circuit, and then I can do some kind of magic, like let me pull some files here, and what will I choose? Here's my kind of oscillator. Now that we are talking about oscillators, this is one kind I enjoy using. So as you can see, this sim program will use this kind of weird ass code. You just copy it, import from text, paste it, okay, and there it is working, and you can see the output it does. And in this case I can use it like an audio synthesizer, because where is the it is, I can change the shape of the waveform. Let's try. This is a very crude way of doing it, but it shows that it works. Let's call this another thing. Let's call it tone, because like in musical instruments, the tone is what makes instruments sound different, even if they are playing the same notes. And as you can see, this thing is loading up because we can play sound. You won't be able to listen to it in my setup here through the video, but whatever, just to show that it works. And the way this is funny, because we can oops, I messed up, hold on. We can, without that thing in the between, we can either have a square wave or a really nice triangle wave. This is a really awesome oscillator in my opinion. Both waves are in the same voltage and in the same frequency and in the same phase. It's awesome. So it's really easy to mix them without odd effects. What else they have good? Well, we can talk about this circuit another time. So now you can use this address here too to test your circuits if you want. I don't really like, you can see the yellow dots here. They mean that they are a way to give sense of current flowing, but because my circuit is such low voltage, high frequency, the balls don't move at all, so it's kind of silly. I don't like it. But the voltaging is quite useful, especially for low frequencies. You can see the parts of the wire which are charged positively or negatively. As you can see, these parts here are ground or pretty much grounded, so they are gray, they are boring color. If you erase this part of the address, more cool stuff happens. You have the smaller applet here. Doesn't matter really, it's more useful when expanded. You press here to expand it to make it full screen as before, or you can have some directions or maybe index of circuits. What this does is, beyond you being able to check the schematics and see them working, you can also read a little bit about it. So let's try to find the op-amp one we were checking out before. Let's see, Schmidt trigger, for example, my Exteresis device. And as you can see, there is a nice description of some notes. This isn't really teaching you how it works, but if you already understand the circuit and are just checking it out in the simulator, you can see comments from the developer. I think I believe not all of the circuits were done by Faultstad, but most of them probably. As you can see, Ian Sharp did the JavaScript port you see for web browser. You can also where is it? You can also is this the link? Can also check the source code and modify it, make your own version of this simulator if you know how to do that. Yep, GitHub, that's right. So what else do I use? Well, I'm using the tutorial points whiteboard to scribble for you, but not really. I don't really use it usually. And I guess mostly use that. When I have a question, I Google it. You can also view YouTube channels. Nowadays there are plenty of nice, decent tutorials on electronics or whatever. Might be hard to find at first, but once you find someone teaching well, they will teach really well all other stuff. So yeah, that's the modus operandi of learning, I guess. just testing a thing, see what you are, see what are your fallacies and misconceptions and such. Talking about misconceptions, let's just go over a couple of them which I find really damning to the person just now understanding electronics. First, you have to consider that the universe, everything, all materials like wood, metal, whatever, we live in an electric universe. If something has electrons, it has electrical effects too. And so, when we categorize materials differently as insulating or conducting or semiconducting, that's a really misleading thing to do, because all materials are actually conducting given enough energy levels. When we talk about insulating materials, what we are talking about is that their resistance, their electrical resistance, or in other words, how they hamper electrical energy, is so high that we don't really notice effects for our purpose. It doesn't really work for the purposes of our circuit. Electrical resistance is measured in ohms, one of the most important measuring units for electricity. People might think it's volts, but not really, depends on what you're doing. They are kind of important given you know the resistance of your circuit and components too, but whatever. So, I think I'll leave this video here for today. Yeah, just think about it. I almost forgot. There's another misconception I wanted to go into. So just to finish this one, all materials are conducting. They just have varying degrees of conduction. They are like a spectrum, like autism or something. So if you talk about insulating materials, means that the material is resisting too much to make our machine work as we intended. And so also another thing about the other misconception is about the speed of electricity. I guess this one isn't as much a misconception. I think many people have already realized that this nowadays, but it used to be a big thing when I was first starting, that people thought about electricity as electrons moving through the materials, and they would move at the speed of light or whatever. They would use the water analogy, which actually is pretty bad, but it works only in certain conditions, very many restraints. I prefer using a pneumatic system as an analogy, like pressurized air in pipes and such. Well, electricity, back to electricity. Electricity isn't really the move of electrons, because electrons don't really move in wires. They are really slow when to make them move, but they can transmit information through each other at the speed of light, indeed. So how is this? You can think of the electrons or atoms in materials as spheres of Newton's cradle. Have you seen a Newton's cradle? It's a bunch of spheres hanging off wires, and if you let one of the spheres go, it will bump into the first one. The following ones won't move until the very last one, which doesn't have any sphere in front of it, will pop out. So energy was transmitted from the first ball to the last one, but the ones in between never really move. They might shake a little, but they don't move at all. Not noticeably. Not notably. So electricity is kind of the same thing. Atoms are transmitting information through each other at the speed of light, but they aren't really moving. In the case of balls bumping into each other, the speed is the speed of sound in that material, so metal balls will have a really high speed. The time it takes for this ball to bump here and then this one pop out is smaller than the time if these balls were made out of wood, for example, which has a lower speed of sound. In case of electrons and atoms, the speed of light is the de facto speed limit. Electrons are pretty much massless almost, so yeah, that makes sense. I don't want to go too much into quantum physics or physics in big words, but that's what. But that's not all. I don't think that's too complicated. That fact there. I think so. These were the two misconceptions about electricity I wanted to go over. Everything is conductive if you have enough power to measure and enough sensitivity to measure it. Everything moves really slow when you really think about it. It's actually the transmission of information that we care about.